My name is Mike Lyon. I'm also referred to as Mikey if you've seen that name pop up around Scale. I'm a senior solutions architect. I joined Scale in 2011, spent some time on the support and product management teams, but now I am a solutions architect primarily supporting our enterprise customers. So that's for us larger distributed entities with 100 sites or more. But what I'd like to be talking about today is an introduction to AIME, which is our autonomous infrastructure management engine. And to give you more clarity on what that is it's an AIOps driven platform that's really designed to simplify the operation of modern infrastructure, right? And we're seeing how AIOps is really becoming a requirement um, really to support infrastructure as code, DevOps, really the ongoing development initiatives, especially as we start to see workloads get transitioned to microservices. How do those get managed at scale? We need to make sure that we're managing our infrastructure as simply and efficiently as we're doing our code. So to talk about that, we're going to cover a few different topics. Specifically, what's the problem that we're trying to solve? Right? What are we actually looking at that's fate that we're facing today? What are these challenges that impact us from a support perspective, from an operational perspective? How can AI, and then specifically AIME, our autonomous infrastructure management engine, solve for that? Let's explain what that is and how it behaves. Specifically, talk about how we use state machines to build models of reality and really to simplify the ongoing management and the traditional background noise that we face from an IT perspective of managing the health of our host, the health of our infrastructure, the health of our software defined management layers, et cetera. And then how we make decisions from observations from that data, right? Because that's really the most important part. Just going back to a design mantra that we've always adhered to is keeping things simple, right? We've always believed that in protocol design, perfection has not been reached when there's nothing left to add, but when there's nothing left to take away. This is a part of RFC 1925, but it really is a great quote, right? And for us, we're leveraging our AI technology to manage all the layers of the stack, hardware and software. We're not leaving the health of the host behind as we perform firmware updates. We're managing everything holistically without any third-party software that's being licensed or recycling any specific open source technology, with no exposed storage protocols, so we're minimizing attack surfaces. We're really providing a platform that is designed for virtual machines, legacy applications, containers, but that is as easy to use as an on-premises private cloud. And how would you expect an on-prem private cloud to behave in a simple, robust, and hardened way? Just like when we're paying for and using cloud resources, we're expecting that they're highly available, expecting them to be managed and updated and maintained. We need to be able to solve that on-prem. But we're dealing with environments that are relatively hostile, specifically unpredictability. There is no consistency necessarily in cooling in data centers. There are power failures, there are surges, there are um, unclean and unreliable network connectivity. Not to mention its hardware itself. There are spinning parts and components still, not just drives, but fans. Hardware fails. It eventually needs to get replaced. How does that failure impact your business, and how does managing and coping that failure and recovering from that failure impact your ability to transact, your ability to operate as an entity? External services fail. We see this probably more often than we should, but we'll look at Down Detector and see different cloud service providers often tied to the same monolithic cloud services. When we see issues with Azure or AWS, it tends to impact upstream other services that are leveraging that technology. So when we have dependencies based on cloud services and those fail, that's compounding the fact that we've got hostile environments working against us, heat and temperature. We've got hardware that's failing. We've got external dependencies, and then software itself is prone to bugs. It's human developed. So there's always going to be an opportunity for improvement. There's always going to be an opportunity to try and improve and streamline that delivery. But at the end of the day, software will fail, and troubleshooting all of these different layers, it's time consuming. It's stressful. We're having to look at data from multiple sources. We're looking at logs from different vendors, oftentimes different management tools to sort through those, identifying trends, identifying patterns, really working within the confines of the data that we have. And this all adds up to just being something that's incredibly complex. And complexity is the enemy of simplicity. I'm not sure who said that, but it really is, very axiomatically true. Um, and the more complex we make our systems, the more layers we add to manage, um, the more brittle and uh, less independent that stack becomes. So, from a management perspective, we wanted to find a way to try and figure out, okay, we can't predict the future, but we can plan for it and we can model behavior based on past experiences, based on past behaviors. We can look at patterns that are occurring not just at the hardware layer, but in terms of the virtual and software layer, the throughput, resource utilization. All of this data is providing us incredible amount of insight into how the system's behaving and how we can plan for outages. We can plan for disruption. We can plan for something that's not necessarily planned on the roadmap, right? We can deal with the unplanned and the unexpected. And we're taking that data, we're storing it, we're forwarding it, and sending that to our AI enabled state machines. I'll talk about what those are in just a little bit here. But it's all leveraging the data that, again, we don't have to sort through those different log sources, uh, solving for that enemy of predictability. That's a complex task, right? It's difficult to break down those different independent layers, those different sources of data, those different sources of truth, and ultimately to build a picture of reality when we're doing it by hand. It's hard to ingest, even if they are machine analyzed logs. We may be trying to pull and correlate data from many different sources. And eventually that event correlation, if you will, becomes challenging. But AI has made that a lot easier. And with Scale and our autonomous infrastructure management engine, we've been doing that for a long time. We've been gathering data, we've been storing it, we've been compartmentalizing and isolating different layers in terms of hardware versus software behavior, each with their own separate monitoring and management layers. But we've been leveraging AI for a long time to take advantage of the ability to recognize patterns, both short term and long range, um, but also to translate those into actionable information. So going back to the definition, what is AIOps? And you could obviously Google this, and you're going to get any number of definitions. They all tend to come back to the idea of utilizing all of the different tools and technologies we have from an AI or machine learning perspective, whether that's ChatGPT to sift through logs and look for patterns, feeding that data to Splunk. Technically, that would fall under the guise of AIOps, but applying those things at scale and taking tools that really are giving automated, data-driven insights, things that are not requiring human intervention, where you don't have to have someone looking for patterns, looking for events, querying large, big data sets. That's all data-driven and automated. We're leveraging machine learning to take advantage of that, to streamline and simplify the data pipeline, the data path. So that way, predictive analytics are just acting on the most important and actionable data, as opposed to having to, again, generate and sift through copious amounts of data for all the different layers within the infrastructure delivery stack, streamlining that data and providing it for analytics, which we can use to, again, model reality, model our current system, and provide some predictive analytics there as well. And take a DevOps approach to managing the core IT functions. So integrating approaches to managing the infrastructure as code, for example, taking advantage of the different log opportunities and data mining opportunities that we have from existing systems, and managing those in a release type cycle, right? And that's going to really take us from a shift from being reactive to proactive, where we can look for patterns, we can look for disks which are not responding as we might expect them to, or maybe have uh, concerning smart data or a temperature sensor on a particular host. We can look for those things ahead of time as opposed to waiting for the temperature to exceed values and then begin causing problems. And that ability to be proactive is really driving a lot of the transformations in the AI ops world. This is Gartner's diagram, and they really talk about three phases of observation, engagement, and then acting. I'm going to drill into this a little bit more with my own spin on it, with four different ideas. But essentially, the idea is saying we're taking the data, we're feeding it through a machine learning algorithm, we're feeding it through AI capable platforms to get actionable information that we can then, like I said, the idea behind AI is that it's all automatic, that we're having tools that are insightful, that aren't necessarily scripts that are built and maintained, but are actually platforms for managing data analysis, platforms for detecting things that are out of the ordinary, and then also translating those into actionable data from a support and operations perspective. Other benefits to AIOps, though, is it's giving us really a focus on everything being data driven. I've said that a few different times, but we want to make sure that we're focused on being data driven, especially from a monitoring and alerting perspective. Right, we want to make sure that the insights that we're getting is coming from multiple sources. That way, as we look and work towards root cause analysis, ultimately for every event, every impact, every casualty, whatever you want to call it, but that we're getting data from multiple different layers in the stack. And that way we can make sure that we're not missing a potential pattern, that there's no gaps in remediation. But again, coming from data driven platforms, things like resource and capacity management become a little more automated, and it's just an organic benefit of AI ops if we're using data driven insights on consumption, specifically if you're using a lot in the cloud. Maybe you're consuming or you're spending a lot more than you're actually consuming. Obviously, you're never going to be told to spend less, but it's a lot of times a good chance for us to optimize and look at what's our current actual utilized resource footprint look like, and is that trending upwards or downwards, and can we impact those trends if we want to try and minimize the footprint. From an ITIL perspective, if you're familiar with ITIL, it was really just a framework around focusing on change management. That was one of its core things. Um, and branching out into that really gives us, with AI ops, it really is a change management driven approach to managing infrastructure. And that's, again, another reason why it's being so heavily embraced is it's giving us the ability to track impacts to the system, to figure out the scope of impact, figure out who's going to be affected, who needs to be involved. Change management is something that IT organizations have traditionally struggled with pretty substantially. And I know that as organizations have adopted more agile methodologies, that's gotten better, but it's still something that really becomes a side effect of using AI ops from a platform and infrastructure component perspective. And then most importantly, it's scalable and flexible. It's something that we can port to different operating systems, different platforms, VMs, containers, Kubernetes. Again, regardless of whether you're using something within the domain of a few clusters or a couple hundred clusters, leveraging those automation tools that Gartner had called out there, provide scalability and give us the ability to manage on a variety of different platforms, including the cloud. Right? So it's giving you the ability to create that hybridized approach, if you will, to making sure that you've got application mobility between the ground and between the cloud, while also minimizing the amount of risks and attack surfaces that you have there as well. And I mentioned ITIL before. It really allows us to focus on being very standards based and standards oriented, focusing on um, fitting in the change management framework, ensuring that we have appropriate controls in the release cycle, even if that's something as simple as making a change to a script or a workload. Is that change going to impact other users, and how is that impact going to be rolled back if necessary? Um, this is an incredibly popular quote, but AI is only as good as the data you have, and the data that trains it, the data that feeds it, the data that fuels it. Every piece of input that goes into a model like that, the garbage in, garbage out methodology is very important, both in terms of system management for us, but also for AI. So if you've got bad data, you're not going to have very good results from an automation perspective. However, with what we've been doing for a very long time in terms of state machine technology, is just gathering these metrics and this data for years. So we know how to act on it, how to behave on it, um, and how to manage the behaviors and manage remediations. Um, and even though it's been said by a lot of people, it really is another axiom of common sense, and we'll come back to that in a little bit. Scale specifically, we're powered by an AI backend. It obviates and really gets rid of the need for any type of IT support. It gets rid of confusing logs, searching through different repositories of events, correlating those together, messages that often blend into one another. It's hard to figure out, even to build in your mind or even in your support system, a timeline of what happened. I just put general nonsense there because from a support perspective, that's really what we're trying to minimize, is filtering out and eliminating spurious, confusing, or otherwise unnecessary messages, really just getting to the point where we're saying a drive is dead, the system is hot, we need to replace a drive in node 2, right? Something very human readable, human understandable, without having to have a tremendous amount of expertise or even IT expertise, because you'd be able to replace that without connecting a crash cart, being able to do that replacement in the field in a completely console-free environment. But that general nonsense, I like to say we're just trying to solve for the background noise of infrastructure management, the challenging things that really impact our day, spending parts of our routine, both at the beginning and ends of day, to see what we missed overnight and validate that everything's going to look healthy before we go home, and trying to minimize our off hours disruption. But that background noise really consumes a substantial amount of time. But our autonomous infrastructure management engine remediates that for us. So it is our own AIOps driven functionality that is coming from HyperCore. It has been in the product since really day one. So what it's doing is it's leveraging our state machines, and I'll talk about how that works, but it's getting data that makes it an updatable model to manage itself, whether that's a single node or a cluster. They're communicating with each other. It is tightly integrated with the hardware level. I know it's great to go and download a community edition of any given piece of software, but the expectation is that there's always going to be, the onus is on you to handle that hardware. We've built a tremendous amount of technology around managing the health of the hardware. So while if you did an initial, out of the box showcase installation on an unknown piece of hardware, we can run, but we're not going to be, once we've imaged and templated that, we'll be far more aware of things that are going on with that hardware, right? So it is deeply integrated. That's why we like to ultimately try and deliver it as an appliance type deployment. Um, Environmental information is coming from a variety of different sources. So vendor hardware collectors, specific NVMe commands for storage information, like I mentioned earlier, smart data, temperature sensors, all these feeding back from a hardware perspective, as well as the virtual and software layer, data latency, making sure the storage is getting allocated properly. All of those things have state machines and collectors associated with those as well. This helps us to predict and ultimately prevent issues. And an example of saying, okay, well, how can you prevent something? We do not have a crystal ball, but like I mentioned, I'll use the hard drive analogy. We can interact with Smart or the vendor specific allocation information in API to figure out when a drive is probably approaching its end of life, as opposed to waiting for it to completely seize, and that would be more of a disruption, right? But as it's reaching the end of its life, we can mirror everything off, as opposed to waiting for that just to become a bigger issue than it has to be. Whereas you can replace that. Again, that's a hot swap process, but that's all being driven by analytics from the state machines, identifying the root cause. We talked about pulling the data in from multiple sources. We're automatically gathering, correlating, and reconciling the data to make sure that we're building a model of reality that makes sense. And then automating the remediation, not notifying and telling you that, hey, you have a problem, you should do this, but just doing it. Because at the end of the day, that's what needs to happen anyway. And this is all a hand-built model of reality. I like to use that term, but it's monitoring the different system states. And our AIOps technology is really a large part of what allows us to build such resilient, highly available platforms. Talk about state machines for a little bit. I've mentioned that term a few times. Really, what we're doing is taking inputs from the system. And those inputs we call conditions, check values. Basically, it's events and it's a data stream of information about what's happening at the system level from a variety of those metrics I mentioned, from latency, VM placement, managing updates, um, data placement, hardware conditions, temperature, etc. Modeling the current reality of what's happening in this particular system, in this particular cluster, this set of clusters, whatever the case is, but it's also very extensible and customizable. So as we add new endpoints to our APIs, we add new features to the product, we can very easily extend and build and model state machines to monitor, to watch, to proactively remediate issues there. So it's very easy for us to grow and scale that as the product matures, as the product evolves. But a state machine is basically saying what is the current state what's a desired state and what's the current state. The desired state for a VM, we want this to be on, its current state is off. We need to take an action upon that. It's just a very remedial example there, but basically it's taking very sensible data structures, information from the system, compartmentalized, things that are very easy to make reasonable actions upon, right? So this is something we've built. It's a large part of our intellectual property. So we've just taken the millions of inputs over a decade to help take that experience and build a simple structure that models reality very well. And what that architecture looks like, just kind of from the ground up. I mentioned collectors. This is really the idea of getting and gathering the data and pulling the information. So we're gathering report system information. It's a very simple methodology, as you can imagine. They're just scraping information, scraping metrics. Maybe it's as simple a Boolean return, but these are compartmentalized based on system function, based on software and hardware. These are customizable, very easy to build. They're interacting with existing system APIs. So both our own APIs like Scribe as well as KVM APIs, disk APIs. So really across the spectrum from hardware and software, as well as at the operating system level, right? For our core OS platform there, making sure that everything is healthy there. So those collectors are feeding into to check values. So the check values are really controlled variables that get updated. They have to be initialized to make sure that they're valid and fresh. So there's consensus between the different hosts, as well as having a number of other checks to make sure that the data has validity to it, that it is not stale, that it is not out of date, that it doesn't model current reality. Using that word compartmentalized again, breaking these down in a per system basis, which means the customization goes very deep. as we break those down. But the check values are fed by collectors. That data is getting fed upstream. And examples of those would be, okay, VM status off or on, disk space, that would be a metric quantity, right? Free RAM, system load, things like that. Those get stored as check values. And then those check values really are just giving us a way to maintain consistency, checking to make sure that they are properly initialized, that there is validity to them, and that they are recent, they are fresh, that these are not expired or stale values that really may not matter because, like we mentioned before, garbage in, garbage out. That's incredibly important for the collectors and check values. We want to make sure that the data we're monitoring is actually real, is reflecting reality. In the example, we have a navigation display, and even though it shows us turning, we've got a particular heading, but there's a failure, right? So the data is invalid. We cannot trust our navigation data. We cannot trust our current heading. We need to use an alternate standby instrument. And that's really what's happening. Is this an example of when garbage data gets detected and flashed up? We're going to account for that to make sure that those check values remain consistent and that they remain relevant to reality. Check values are cluster-wide. They're shared among multiple subsystems. This is very easy to grab that data from the UI, from the API, but they're feeding up conditions. Dealing with conditions which are ultimately undesirable or what we're going to see from a human perspective. They are either set or clear. It's a Boolean state, but it's basically saying a condition is something that is undesirable, or as I say, it's going to require human intervention. We've got free disk space that's very low. That was collected data, fed up to a check value, created a condition. A human's going to have to do something about that, right? We're going to have to log in. That was an undesirable state, and we need to expand the disk, clear up some data, whatever the case is. From a data expiration standpoint, again, that's something we also, collectors fail. This is software and hardware. So if something doesn't return valid data, we make sure that we're not going to trust that. And like I mentioned in the previous example, there's going to be a standby, right? So when we deal with invalid data that's either expired or aged, we're going to have another source of truth to be able to query from that. Queryable history, I just called it there, but this is all going to provide us a very detailed trail and itinerary of what happened, and it's going to give us a timeline so we can go and very easily play back the state machine activities of what happened. This is an example of the state machine giving us conditions that are easy and simple to read from a support perspective. I can't send alerts. I've got data redundancy degraded. I need to migrate a VM back. These are very easy things that can also get sent as emails. I can also get sent as conditions in the user interface, but it's human readable. And that's translating into a state machine. It's a model built of current reality, of the reality that's happening now, but it also is one that's based on millions of data points. It's based on history. It's based on getting the system to its desired state. Just to expand very briefly on the Gartner diagram, I like to talk about AIOps as being the OODA loop, where it's a problem-solving methodology wherein we're just observing, orienting, deciding, and act. From an observation perspective, collect current data, get a wide field of view, what's happening and what is wrong. Now let's analyze that data to reflect my current reality. Make sense of what's going on here and now. And now that I've collected the data and made sense, I need to determine a course of action that's going to make sense based on the observations that have already been made. I need to power this VM on. I need to clear more space, and then act, follow through. We've been given a specific directive based on the observations, based on orientations around the data. The decision's been made, and now it's time to act. Right? Execute, follow through, and solve the problem. And at the end of the day, it's all about IT operations, simplifying them, right? So as more and more acronyms get thrown at us, just remember AIOps is a way to try and simplify and automate the current task of remediation and troubleshooting that we're facing today. And Scale has a very robust AIOps engine built in, our autonomous infrastructure management engine. And it's been around for quite a while. We just decided to latch on to the AIOps terminology since it seemed to be the buzzword as of late. But at the end of the day, it's our AI-driven system built off of state machines and technology that's modeling current reality. So thank you for your time. Hope you enjoy the rest of the sessions.